Town region. Hello, my name is Ufoma, and this is going to be my first video on the AWS series. And I'm excited to let you know that for folks in Nigeria and West Africa, the Lagos Availability Zone is up and running. AWS announced that yesterday, and the purpose of this video is to show you how to enable it on your console and take advantage of the low latency that it can offer for your resources. All right, so if you come down here in the announcement, you'll see that you can enable AWS local zones from the Zones tab in settings of the Amazon of your EC2 console. So if you have not already enabled the AF South 1 region, which is the Africa, the Cape Town region, then you cannot take advantage of the availability zone. So the first thing we're going to do is to take you through how to enable your Cape Town region, and then go on to show you how to enable the Lagos availability zone. So let's go. So right now, this is my EC2 console, and if you take note, you'll see we are in the US East 1 region, the US East 1 region. So the first thing we need to do is to enable our region by, for those who have not enabled their Cape Town region, you hit the regions tab. I have enabled mine, that's why you can see it here. So you scroll down to enable your Cape Town region. You come down there here to regions, right? And you select regions, manage regions. And it takes you to this page. So ordinarily, by default, the Cape Town region is disabled. So it looks something like this. The status shows disabled, but I have enabled mine, right? So when it shows disabled, all you need to do is to come to the action column and hit enable, right? And then you say enable region. That's all you need to do. And it takes about 5 minutes for it to get enabled. Once that is done, and then we can go back to our EC2 console and then come to your account attributes and click on zones. Here you will see a list of zones that are disabled. Right now we are in the North Virginia region, the US East 1. So we're going to switch to the Africa region, the Cape Town region, AF South 1. And here you see I have enabled my Lagos region. But if in your case, if you have not enabled your region, you'll see how it will be in red print showing disabled, right? So all you need to do if it's disabled is to hit your manage button, and then you select enabled. In my case, I have already enabled it. So you select enabled and you update your zone group. That's all you need to do, and it will be enabled. And once that is done, the first thing we can do is to create a subnet based on that availability zone, so that we can take advantage of that. We can create resources, provision resources in that subnet that is located in the availability zone. So let's go. We go to our VPC console. This is our VPC console, right? And then we click on subnet. You know, by default, every region you go, AWS creates your networking infrastructure, default network infrastructure. So you have your subnets, you have your VPC, you know, all set up. Yeah. So we go to subnets, we hit create subnet, we select our VPC, we give our subnet a name, We hit our availability zone. Here is where we select the Lagos AF South 1 LOS 1A, and then we give a CID arrow number, and it's tagged already. Yeah, correct. And then we create our subnet. So our subnet is available. We have our Lagos subnet, so we can go ahead and provision resources on our Lagos subnet. I'm just doing this, don't mind all this. I'm just doing it to show you how it works, right? And so we come back to our EC2 console. We'll click launch launch instance. We give it a name. Let's give it Lagos server. We take a T3 micro. We select our key pair if we have to, and then we edit our network settings. We keep to our VPC, and here on the subnet we can go and select our newly created subnet, right? Yeah, you can go back to your VPC and enable, make it internet facing if you want. You can come back to your VPC, select the subnet, and make it internet facing, right? And save it, right? All I did was to come to my actions, and then you go to edit subnet settings, and then you see, when you click that, you see enable auto assign public IPv4 address. It was disabled before, but I enabled it. So that makes your subnet internet facing, right? So that's all you do, right, to get your subnet to be internet facing. So we come back here to our EC2 console, we refresh, we select our subnet again, and you see it will have an auto assigned public IP address. So that's about it. That's how you can take advantage of the the newly created Lagos subnet. Thank you very much. I hope you like it. You can make your comments if you want to get more videos from me, and tell me what you'd like me to create, and I'll do it. Thank you. Hope to see you soon. Bye. Hello. Okay. Here, this is Ufoma, and welcome back to my channel. So, the first thing I want to do today is to show you how to copy files from your local machine to your cloud server. Okay, let's go. Here is our cloud server, and we are using AWS as our cloud provider. So I have my cloud server here. Select your cloud server. Hit connect. Copy the command. Come to your terminal. CD to your key pair location. Mine is in the desktop. And then paste. Hit enter. Yes. And we're in. And then go to your root. Clear the screen. Okay, so here we are in our root as our server, cloud server. So what we want to do here is to create a directory where we want our file to be copied into. So let's make a directory. Let's call it data inflow. Let's ls to check. Yeah, we have a data inflow there. And then let's cd into our data inflow. And then with ls, there's nothing there. Good. So let's check our absolute path. Great. Okay, so we're going to change ownership to EC2 user, right, at this present location. We'll do the same thing on the root location, and then the root directory, and then we're done. So let's cd back to data inflow. Great. So we're done. So now the next thing we're going to do is to go to our local machine. So this is our local machine. This is a terminal. And then we can, let's cd into, let's say, my documents. So I'll cd into my documents, right? And let's make a directory, data storage. And then let's cd into data storage. That's ls, nothing is there. Let's make a file, right? Create a file. Let's call it data.txt, and then let's put something inside our file. So let's say great, Command D. Oh, sorry. Control D. So we are done. Let's ls there. We have our data.txt, and let's cut it. Great. So this is it. So we'll clear the screen, and the next thing we're going to do is to bring our key pair to this very data storage directory, right? Because we're going to be using SSH to move the file, SSH protocol to move the file from the local machine to the cloud server. So let's go. My key pair is on my desktop. So let's cd to my desktop. And then let's check. Okay, that's my absolute path. So I'll copy this. Great, and I'll go back to my my data storage. Okay, great. So now I'm going to copy my key pair to this very location. So I'm done with that. If I ls, you see that my key pair is there. Clear the screen, and now I'm going to use secure copy to copy my file to EC2 user art. I'll come here and I'll take my public IP of the server, select the server. Here is my public IP address. Come back to my terminal and I'll paste it there, and on full column and root, that's the location where you want your your data to go to. So which is root/data inflow, and this is the location in my cloud server, right? So I want this file to use the secure copy command to use my my SSH, that's my key pair, using my key pair to transfer this data to this location, to this server, and to this very directory. So let's go. Yeah, it's done. So let's come back to our cloud server, and let's check our data inflow. Let's ls. Yeah, we've got that. Let's cut the data file, and let's see what's inside. Great. This is how to copy files from your local machine to your cloud server. I hope you like this. See you later. I just want to show you quickly how to create an EC2 instance. Okay, so let's log back in to your console. And this is the URL. That's it there. Make sure you note that URL. And here you put your user email if you are logging in as a root user, which is not recommended, but for the purpose of just creating an EC2 instance, we'll use that, and then we'll hit next. We'll put our password. And then you come to your services, right? Your services tab. That's where it is. This, you come here, right? Or you come on type EC2 here. I know that's the EC2, but you can, come to any of those places to get your EC2 service, and then we click on EC2. We click on launch instance. Launch instance. We give it a name. We come down here and select an image, a virtual image. This is AWS, Amazon Linux. If you want to use a Mac OS, if you want to use Ubuntu or Red Hat or Windows, I'll take Ubuntu in this case. And then you check if your system is an AMD, you select 64-bit. If it's an ARM, then you go for this. But mine is a 64-bit times 86 system, and then you select that, and then you come to your instance type. This is tells you the spec of your instance, your CPU, your compute spec, so your memory and your CPU. For now, let's go for free tier, but you have a number of choices to make, but free tier T2 Micro is the one to go for if you're just starting. And then your key pair, this will enable us to log in on to get access into our system at the back end. So you select your key pair. I'll do another video on how to create a key pair. So for the purpose of this, I'll select my key pair, and then your network settings. You want your computer, your instance, to be created in a private network. So your virtual private cloud network, you select your VPC, your subnet, and make sure the system you're trying to create is enabled to have a public IP, so people can access your system from outside, from the internet. So I just want to hit edit, so you can, if you have more than one VPCs, I'll do a video on VPC. You can select your VPC, and then you pick your subnet, and make sure your subnet, for you to be able to enable your instance to have a public IP, your subnet must be a public subnet. In other words, your subnet must be a public subnet, basically. I'll talk about that later in another video. And then you either create a security group, which is a firewall, or an existing one that you already have. I'll choose the existing one I already have, because I'm going to do another video on how to create a security group. Great. So I'll just hit that one, and this is your storage configuration. I'll leave it at 8 GB, and the number of instances, I'll leave it at 1, and then we'll launch our instance, and then we'll watch it's a success, and then we select instances there, and this is a previous instance, but this is the new one we just created, and we wait for it to show running. So we'll just refresh a little bit. Oh, great. So that's running. So this is how to create your instance. If you select the instance, you'll see more details on your firewall, your networking, your storage, your status checks from the Amazon perspective and from your perspective on this side, right? And then your monitoring dashboard and any tags you've given. So We'll talk about all these in a later video. I want to do short videos that go straight to the point and show you what to do, and I don't want to talk too much. So if you think you've learned something today, well, yeah, you can do me a favor by hitting the like button, telling me what you learned, a comment, and subscribing to my channel. Thank you very much. Hello, this is Ufoma again. I want to show you how to create a key pair. Key pairs are used as security tools that are used to enable a user to log in. So quickly, let's go. Let's assume right now we have two instances running. Let's take my new instance, right? We want to log into this instance and there is no key pair, right? Then what do we need to do? We need to create a key pair. Under your network and security, you will see key pairs. Select key pair, come straight to create a key pair, give it a name that you want, new key pair. You leave it at the RSA option, and then always select the .pem option, except probably you're using Windows and you need to use PuTTY, but just leave it at the .pem option. And then if you like, you create a tag. So let's create a key pair. And voila, we're done. That's a new key pair. That's it there. And for you to know, your key pair downloads the .pem file. It actually downloads it in your computer. So what you need to do is to make sure you locate where it's downloaded. Go to my downloads file, and that's my new key pair, right? So if you think you've learned something in this video, you can subscribe. It will do me a great favor. Follow me, put a comment down on what you've learned, how to create a new key pair. I'll just quickly show you how to use it. So you come to an instance, you click Launch Instances. Great, you give your instance a name. Okay, we've gone through this before, but this is how to use a key pair. After filling all this information, you come straight down to the point you have to see where you find key pair. So here you select the key pair you just created, and that's how to use a key pair. And then you fill in the other information. If you look at my video how to create launch an EC2 instance, you will see where I used this key pair. I used the key pair when we got to this section. So this is how to create a key pair and how to use it. If you feel this video is informative and you've learned something, do me well to subscribe, hit the like button so you get more short videos like this, and also put a comment, one or two below, on what you want me to a video you want me to make. Thank you. See you next time. Hello. All right. This is Ufoma, and in this video, I want to show you how to gain access into your virtual computer, your virtual server. So the way to gain access into your virtual server is through an SSH protocol. And one of the videos, you will see one of my videos, how to create an SSH key pair, right? A key pair for SSHing into your remote server. So we'll go ahead straight away and launch into our server. So I'll take this new instance, right? You select your instance, that's the first thing you do. And then in your instance, you look for your public IP. And here you have your public IP. You select your public IP, and then you go to your terminal or you go to your terminal. Right, in your terminal, you locate the place where your key pair. In your terminal, you need to CD to the location of your key pair, the downloaded key pair. Remember, when you create your key pair, the the part of that key pair is downloaded and in your system, in your local computer. You need to CD into that very location from where you can SSH into your key pair. So if I ls this, I see that I have one key pair there. I have another key pair here. So, I mean, let me use this one, right? I can decide to use this key pair, right? So what I need to do here is you use SSH, that's the protocol, in an interactive mode. Then the key pair name, .pem, always remember to put the file type, and then what kind of AMI are you using? Are you using Red Hat? Are you using Amazon? If it's Amazon, then you should be using EC2 user, right? If it's Debian, Ubuntu, you need to use Ubuntu. So I'm using Debian Ubuntu. So Ubuntu at your public IP, the one we copied earlier, and then you hit enter, you hit yes. Yes, and that's the way to SSH into your EC2 instance. If you think this video is informative and you like what you just learned, put a comment below. You know, you do me a great favor if you subscribe and hit the like button, and you know, let me know what you want me to create next. Thank you. Bye. Hello, this is Ufoma again. I want to show you how to create a key pair. You know, key pairs are used as security tools that are used to enable a user to log into an instance at the back end. So the first thing you need to do is to scroll down. Under your network and security, you will see key pairs. Select key pair, come straight to create a key pair, give it a name that you want. New key pair. You leave it at the RSA option, and then always select the .pem option, and then if you like, you create a tag. So let's create a key pair, and voila, we're done. That's a new key pair. That's it there. And for you to know, your key pair downloads the .pem file in your computer. So what you need to do is to make sure you locate where it's downloaded. Go to my downloads file, and that's my new key pair, right? So if you think you've learned something in this video, you can subscribe. It will do me a great favor. Follow me, put a comment down on what you've learned, how to create a new key pair. I'll just quickly show you how to use it. You click launch instances. Great, you give your instance a name. After filling all this information, you come straight down to the point you have to see where you find key pair. So here you select the key pair you just created, and that's how to use a key pair. And then you fill in the other information. If you look at my video how to create launch an EC2 instance, you will see where I used this key pair. I used the key pair when we got to this section. So this is how to create a key pair. If you feel this video is informative and you've learned something, do me well to subscribe, hit the like button so you get more short videos like this, and also put a comment, one or two below, on what you want me to a video you want me to make. Thank you. See you next time. Hello. All right, this is Ufoma, and in this video I want to show you how to gain access into your virtual computer, your virtual server. So the way to gain access into your virtual server is through an SSH protocol. And one of the videos, you will see one of my videos, how to create an SSH key pair, right? A key pair for SSHing into your remote server. So we'll go ahead straight away and launch into our server. So I'll take this new instance, right? You select your instance, that's the first thing you do. And then in your instance, here you have your public IP. You select your public IP. You go to your terminal. In your terminal, you need to CD to the location of your key pair, and in your system, in your local computer. you need to CD into that very location from where you can SSH into your key pair. So if I ls this, I see that I have one key pair there. I have another key pair here. So, I mean, let me use this one, right? I can decide to use this key pair, right? So what I need to do here is you use SSH, that's the protocol, in an interactive mode. Then the key pair name .pem. Always remember to put the file type, and then what kind of AMI are you using? Are you using Red Hat? Are you using Amazon? If it's Amazon, then you should be using EC2 user, right? If it's Debian, Ubuntu, you need to use Ubuntu. So I'm using Debian Ubuntu. So Ubuntu at your public IP, the one we copied earlier, and then you hit enter, you hit yes. Yes, and that's the way to SSH into your EC2 instance. If you think this video is informative and you like what you just learned, put a comment below. You know, you do me a great favor if you subscribe and hit the like button, and let me know what you want me to create next. Thank you. Bye. Hello. All right. This is Ufoma, and in this video, I want to show you how to gain access into your virtual computer, your virtual server. So the way to gain access into your virtual server is through an SSH protocol. And one of the videos, you will see one of my videos, how to create an SSH key pair, right? A key pair for SSHing into your remote server. So we'll go ahead straight away and launch into our server. So I'll take this new instance, right? You select your instance, that's the first thing you do. And then in your instance, here you have your public IP. You select your public IP. You go to your terminal. In your terminal, you need to CD to the location of your key pair, and in your system, in your local computer, you need to CD into that very location from where you can SSH into your key pair. So if I ls this, I see that I have one key pair there. I have another key pair here. So, I mean, let me use this one, right? I can decide to use this key pair, right? So what I need to do here is you use SSH, that's the protocol, in an interactive mode. Then the key pair name .pem. Always remember to put the file type, and then what kind of AMI are you using? Are you using Red Hat? Are you using Amazon? If it's Amazon, then you should be using EC2 user, right? If it's Debian, Ubuntu, you need to use Ubuntu. So I'm using Debian Ubuntu. So Ubuntu at your public IP, the one we copied earlier, and then you hit enter, you hit yes. Yes, and that's the way to SSH into your EC2 instance. If you think this video is informative and you like what you just learned, put a comment below. You know, you do me a great favor if you subscribe and hit the like button, and let me know what you want me to create next. Thank you. Bye. Hello there, this is Ufoma again, and welcome to my channel. Today we're going to do a short video on how to create NAT gateways. NAT gateways are very great tools for your applications that are in your private subnet to access the internet for stuff like updates and upgrades. You know, by security standards, all your applications should be in your private subnet, and so you would want to have a NAT gateway in your public subnet So you can hook up to your NAT gateway and gain access, one-way access to the internet to update your applications that are in the private subnet. So the way the architecture works is your NAT gateway is created in your public subnet, but it is associated with a route table in your private subnet. So that way it creates a connection with all the applications in your private subnet. So that way the applications in your private subnet are able to get on the internet and do updates or upgrades, via the NAT gateway, which is provisioned in the public subnet, but associated with the private route table. Now, without further ado, let's go. So the first thing we need to do is we can decide to click here and look for a NAT gateway, which is you have up there. But let's use our tab to select locate your virtual private cloud. Come down to where you have NAT gateways, select NAT gateway. Right now we have no NAT gateways. On your top right, click create NAT gateway. Give your NAT gateway name. Select a subnet in which you want your NAT gateway to be provisioned. So this is where it gets tricky. Your NAT gateway must be provisioned in the public subnet for it to be able to be effective. So here is we already have subnets that we've tagged, public and private subnets. So I'll go for the public subnet and I'll create my NAT gateway in a public subnet. And I want my NAT gateway to have public connectivity so that it can hit the internet. And then if you have an elastic IP, I did a video on how to create an elastic IP. Here is where you can allocate and associate your elastic IP with your NAT gateway. If you do not, by default, NAT gateways will create an elastic IP for you. And then we come down to our tags, and you give your key a name. You assign name to your key, and the value you give it the name of your NAT gateway. It's already done that for us, so we just go ahead and hit create NAT gateway. So it tells us here now that we have to assign an elastic IP to our NAT gateway. So this is where we have to go create an elastic IP. So once you hit allocate elastic IP, it automatically assigns an elastic IP for you, and you can now go ahead and create your NAT gateway. So we have our NAT gateway created, and it takes a while before it gets created and running. So what we've done here effectively is our NAT gateway has been created. The next thing we need to do is to go to our route tables and look for our private route table, and then associate our NAT gateway with our private route table. We'll come to edit, we'll come to routes, come to edit, select edit, come to add route. You select the destination, that is traffic is going outside. When you see 0.0.0/0, it means you're allowing traffic to go out, right? And then the target, if traffic has to go out in your private subnet, remember this is our private route table. If traffic has to go out, target from any application in your private subnet. If traffic has to go out to the internet, target the NAT gateway. So you go there and you select your NAT gateway. And this is a NAT gateway we created, my test NAT gateway. Select it and hit save changes. So what we have effectively done is to create a NAT gateway that helps us to get to the internet and update and upgrade applications that are in our private subnets. This is the private route table, and if you come to subnet associations, you will see
the subnets that are associated with this route table are private subnets. The reason is they do not have internet gateway associated with them. Private subnets, mostly you have, what you get to see is a NAT gateway associated with your private subnet, and that NAT gateway must be provisioned in your public subnet. So when you applications in your private subnet need to ask to get to the internet, they need to get outside your VPC to the internet. The target, the resource that they will target is your NAT gateway. And guess what? Your NAT gateway is provisioned in your public subnet. So they go, when they target your NAT gateway, the NAT gateway has access to the internet, and it only allows one-way access. So you cannot gain access from outside into your private subnet via your NAT gateway. It's not possible. The only way to gain access into your private subnet is through your internet gateway, and from there on through security groups, load balancers, and whatever your infrastructure setup is. So I hope you like this video. If you've learned something from this video, do well to hit the like button, subscribe, put on comment below, and let me know what you want me to make for you. Thank you very much. Bye. Hello there, this is Ufoma again, and I'm going to show you how to create an elastic IP. This is going to be a short video, so I'm going straight to the point. If you are in your EC2 dashboard, come down to Network and Security, select Elastic IP. If you are in your VPC dashboard, under Virtual Private Cloud, come down to Elastic IP, select Elastic IP. From then on, in your EC2, go to your top right and click Allocate Elastic IP Address. In your VPC, go straight to your top right and do the same. Now you don't have to create Elastic IP in both services. I'm just trying to show you that you can create Elastic IP in your VPC as well as in your EC2. So any one of them will do. From here on, it's the same procedure. Let's go back to our EC2. You see, it's the same procedure. Come back to our VPC, the same procedure. So what do we do here? Under Network Border Group, click on the tab and select your availability zone. And then scroll down to your tags and hit Add New Tag. In your key, enter name. We want to name our EIP. And under value, enter the name you want to assign to your EIP. In this case, I'll give it NAT Gateway EIP. Now, click Allocate. And that's how you create your Elastic IP. If we come to our VPC, since we've created our Elastic IP in our EC2 dashboard, we can hit Cancel. And when we come to our EIP, we see that we have an Elastic IP named NAT Gateway Elastic IP. Okay, if you're done with using the Elastic IP, you want to delete it, you come to Actions and you click Release Elastic IP, and then you hit Release. That removes your Elastic IP effectively. If you come to your EC2 dashboard and you hit Refresh, no more Elastic IP. Thank you for this video. If you think you liked the video, you've learned something from this video, do well to follow me, hit the like button, and put a comment down there to encourage me and to let me know what other short videos you want me to make. Goodbye. Hello, this is Ufoma again, and today I'm going to show you how to create security groups. Security groups are firewalls that help you boost the security of your applications in your VPC. Without further ado, let's go. Now, in your EC2 dashboard, scroll down to Network and Security and hit Security Groups. In your VPC, scroll down to security and click security groups. So what I mean here, what I'm trying to show you here is you can create security groups through the VPC service or through the EC2 service. You can do the same. So for now, let's use the EC2 service. Come to your top right and click create security group. Give your security group a name, add a description, select your VPC. The VPC is already selected, and then we come to our inbound rules. This effectively lets you define what kind of what the ports that will be open and what kind of protocol whoever is going to access your application or your network is going to be allowed to use to gain access into your network. So if we hit add rule, we have the type of protocol here. You have a custom TCP, but remember up here in our description we put that we want to allow SSH on port 22. So we go to our protocol and we look for SSH. That's it there. Select SSH. By default, the port for SSH is port 22. So for your SSH, you want a secure connection to your application. So you select my IP. That's the best security practice. So no other person can gain access except those you allow. So if I select my IP, that effectively gives me access on port 22 to my application. If I select HTTP, you want everybody to have access to your application via HTTP or HTTPS. So I can select everywhere, anywhere, and that's your IP address will be 0.0.0/0, which means anybody can gain access. And your HTTPS, you can select the same thing. In your outbound rule, you want to leave it at the way it is because you want your application to gain access to the outside your VPC unrestricted. Add a tag, scroll down to your tag, add a tag, enter name. You already picked it for us. And in your value, enter my test subnet. Scroll down and hit create security group. And that is how to create a security group. Thank you very much. If there is any other short video you want me to create, do well to hit the like button, subscribe if you think you've learned something, and put a comment below to let me know what you really want me to create. Thank you. Bye. Hello there, this is Ufoma again, and today I'm going to show you how to create a virtual private cloud. That's VPC. And without further ado, let's start. The first thing you need to do is to come up here to your on your VPC dashboard, come to create VPC, select create VPC, come to VPC settings, select VPC only. If you want to create VPC and more stuff, you can hit this and then build your network. But I want to show you just for VPC. You select VPC only, give your VPC a name, select your IPv4 address for your VPC. And we'll leave our tenancy at default. We give a name. Our tag is already prepared for us, and then we hit create VPC. We'll come to our VPC tab, select VPC, and here is my test VPC. So this is how to create a VPC. Thank you. If you think you like this channel, you've learned something, you like as we go straight to the point, do well to follow me. Hit the like button, put a comment there, and I'll do a short video of your interest if you put a comment and let me know. Thank you very much. Bye. Hello, this is Ufoma again. Today I want to show you how to create a public subnet and a private subnet. Now the difference between a public subnet and a private subnet is which one has the route table associated with an internet gateway. So by the way things work, when you create your VPC, in your VPC you will have subnets, and in those subnets you decide which route table you will associate your subnets to. So if you have two subnets, subnet A and subnet B, and you associate subnet A to route table 1, and you associate subnet B to route table 2, and then you go ahead to associate the internet gateway to route table 1, you've effectively made subnet A a public subnet, while subnet B will be a private subnet because there is no internet gateway associated with subnet B. Let's just go ahead and create subnets. So under virtual private cloud, you hit subnet and come down up to your right and hit create subnet, and you select a VPC where you want your subnet to be created, and then we give a subnet a name. And then we select an availability zone. Let's choose US East 1A, and then we give an IPR and IPv4 CIDR block address. In this case, our associated VPC is on 192.0.0/16, so we'll give 192.0. Let's say .9.0, and then under your tag, always use name, and then we'll give it a name. So it's already done that for us. So we hit create subnet. Now this subnet is created, but it's not associated with any route table. So under route tables, you come to route tables under your virtual private cloud. You click route table. You wait for it to load. So here I have a public route table that I named public route table simply because I have the internet gateway associated with this public route table. Select your public route table, or select your route table. So come down to routes, and here in the route you'll see that there is an internet gateway associated. This effectively makes all the subnets that are in your subnet associations tab public subnets. So if I want to make this newly created subnet, which is here, my test subnet, a public subnet, all I need to do is to edit subnet associations and then select my preferred subnet and hit save associations. So if you come to subnet associations, you'll see my test subnet, meaning this subnet with this IP address is effectively a public subnet. If I create a second subnet and I do not associate it with the route table that has an internet gateway, that effectively makes that subnet a private subnet. I hope you like this video. If you want to learn more, hit the like button, subscribe, and put a comment below to let me know what you want me to create next. I like short videos because I like going straight to the point to teach you what you need to know. Thank you. Bye. Hello, welcome back to my channel. Today I'm going to show you how to create an IAM role, right? So the first thing we're going to do here is to come to your role, select role, click create role, and then if you're going to be using the role for a service like EC2, for example, select AWS service. So I'll click that and then select the actual service. In this case, I'll use EC2. Hit next.
and then come here and search for the role you want to create. In this case, I want to create a role for EC2 to be able to use Systems Manager to log into your instance. So I'm going to search for that policy, and here is the policy. Then you select the policy, you click next, you give it a name, the role a name. So let's say EC2, let's say some connect. That should be enough for me. Okay, great. And that should be it. So we click create role, and that's it. We've created a new role that allows us to use Systems Manager to gain access into our EC2 instance. So if you like this video, do well to give me a thumbs up, click the like button, subscribe, put a comment below to let me know what next you want to create, what videos you want me to do next, and I'll be glad to do. Thank you. Bye bye. Okay guys, today let's explore how to create an S3 bucket, right? An S3 bucket is a virtual storage device, right, that helps us keep our data, store our data and retrieve our data anytime. So first thing we need to do is to click on that, right, to create our S3 bucket, and then we give it a unique name. It's always unique. You can have only one name anywhere in the world. And then, so let's see, is it there? Okay. So here we're going to now select the region where we want the bucket to be provisioned. If you see here, you'll see that the S3 service is a global service, right? It's global in nature, but you need to provision your bucket in a specific region. So we'll take US East 1 by default, right? And I'll leave access control lists disabled. I'll leave my block all public access enabled. And I think this is just this is it. Let's create our bucket, and that's it. This is how to create an S3 bucket. That's the name there. If you think you've learned something as a beginner, give me a thumbs up. Subscribe if you feel the need to do so. Put a comment below to let me know what you want me to create next. Thank you. Okay, welcome back to my channel. Today, let's see how we can create a static website. You can have a website of your own, just a simple website. I'm going to show you how to do that using S3 on AWS. The first thing we're going to do is to create a bucket, an S3 bucket, right? And then we'll give it a unique name. As you know, S3 buckets have unique names worldwide, globally. So yeah, let's give it this name. Next thing is we have to provision it in a region. By default, we are on US East 1, so we'll take that. Access control list, we're going to work on that. And then we're going to deselect block all public access because we want it to be accessible to the public. And we're going to accept our choice, right? And basically, that's all we need we create our bucket. Yeah. So now that the bucket is created, to do is to prepare the bucket to be able to host the website. So select the bucket, come to permissions, and under the bucket policy, we are going to edit it and impute a policy that allows the public to get in. So yeah, that's the place, we're going to put that policy. So we'll go to AWS documentation. I'll put a link in the description below. And we're going to, it's always good to check AWS documentation when you're working, right? So the only thing we're going to change here is the bucket name. So we'll copy that. We'll come back here and we'll paste the policy here and go up there and pick our bucket name. Yeah. And then let's copy. Then we'll come back and remove that name. And then you paste our bucket name. And that's all you have to do here. By doing this, you have made it possible for people to be able to access your bucket. So under properties, we'll scroll down to static website hosting. We edit it and then we enable static website hosting option. And then under our index document, that is a document that we use to host our that you would see online. We'll give it a name, index.html, and that's about it, right? And then we'll save our changes. So we've effectually prepared our bucket to be able to receive our code, right? So under the objects tab, right, this is where you can now upload your code. So what we're going to do now is to click upload, right, and then we go to add files. In this case, when we locate our code, where is my code? That's it there. We have two files to add at the root of the bucket, so I'll select both of them and then I'll upload those. I'll also go back to add a folder and pick that image folder and upload, right? And then I scroll down and I'll click upload. So I'll watch for the status to make sure everything is successful. Great, all successful. So I'll close, and effectively our code is uploaded, our bucket is public, and we have a policy that allows public access. So on our properties tab, we can now scroll to the bottom and copy our S3 endpoint, right? And then we go to a browser and paste the endpoint so we can view our website. And that's it. That's our website. Yeah. So if you're a beginner and you think you've gained something from this video, like my channel. Maybe if you think it's going to help me, I know it will help me. Subscribe to my channel and put a comment below to let me know what you want me to create next. Thank you. Okay, so in the world of containerization, containers, Docker containers and all the kind of containers that are out there, you will quickly find out that you will need to have a registry, where you need to store your images. And the good thing is that AWS has its own Elastic Container Registry with which you can store your images. So I'm going to show you how to create a public and private registry. So we hit create registry, and there is the option for you to choose whether you want to do a public or a private. For now, I'm going to select the private. And just remember that your registries have a unique name, right? Just like your emails. So we're going to create a name for your registry. Let's give this okay. So this is just it does the same thing that Docker Hub does. So if you have a Docker Hub registry, it's the same thing, but this is just cloud native to AWS. And that's all you need to do. You click, and we have our private registry. You can import your Docker containers, your Docker images, to that. Let's go ahead and create a public registry. Do the same thing, given a name. Okay, I'll change that to public. And basically, for starters, that's enough, right? That's enough. So we'll click registry, create registry, and that's it. So we have a public registry as well as a private registry. So another thing I'm going to show you is how do you connect it to your terminal, right? That's the public registry. For example, you select and then you click view push commands, and the first command you find there is what you're going to use, right? You copy that, you go to your terminal, and then you paste, right? So let's paste that, and all that does is to authenticate you as a user, an AWS user, to that particular registry, right? Before you do this, you would have configured your AWS CLI, all right, and you would have entered in your password, passkey, and your secret passkey. You would have done all that, right? And when you hit enter, it takes a little while, but eventually it's going to log in. So once this is done, yeah, that's it, login succeeded. You can now build your Docker images and push them directly to AWS Elastic Container Registry. So if as a beginner you've learned something new, it's not a bad idea to give me a thumbs up. Also not a bad idea to subscribe and put a comment below to let me know what videos you want me to create next. Thank you very much. I'll see you next time. Imagine you're setting up a computer lab and you want all the computers to have the same settings and configurations. Instead of manually configuring each computer one by one, you create a template that includes all the settings you want. This template can be used to set up multiple computers with the same settings quickly and easily. If you ever need to change something, you update the template and all the computers that use it will automatically have new settings. Now let's create our first template. On your EC2 dashboard, on the left side, under Instances, click Launch Templates. Click Create Launch Template. Give your template a name. Give your template a version description. If you need to use your launch template for auto scaling, select this option. Give your template a tag. Click Add New Tag, enter a key. I'll take name as my key. Give the same value you gave for the name of your launch template. Select your preferred AMI. Select your AMI. Select your instance type. Select your key pair. Select your subnet. So I'll say don't include in launch template. Select your security group. Select your storage. Click on advanced. Scroll down and input any application or dependency or package you want to install with your template. Click Create Launch Template. Your launch template is created. To see details of your launch template, select the launch template. And here are the details of your launch template. You have your AMI, your instance type, your security group, your key pair, the name of your launch template, your launch template ID, your version, and the owner. So this is how to create a launch template. You can now proceed to your auto scaling group. If you want to use your launch template for auto scaling, create auto scaling group. You can give it a name. And here is where you will need to select your template. So when you set your values for your desired and your minimum values for your auto scaling group, your auto scaling resource is going to create an EC2 instance based on your launch template. So that's it for this video. I hope you like it. If you want to get more videos and if you think you've learned something today, do well to subscribe. It helps me a lot. And click the like button and hit the notification bell. And let me know in the comments below what videos you want me to create next. Thank you and bye. Today, let's talk about auto-scaling groups. Auto-scaling groups are a feature provided by AWS that allows you to automatically adjust the number of instances in a group based on the conditions you define. So it all depends on the condition that you define. Auto-scaling groups are fundamental components of AWS auto-scaling service, which helps you maintain the availability and scalability of your applications. So are critical components of designing scalable and highly available applications on AWS. They allow you to ensure that your applications can handle varying levels of traffic while maintaining reliability and cost effectiveness. Let's see how we can create an auto-scaling group. On your EC2 console, scroll down to auto-scaling group. Click Create Auto-Scaling Group. Give it a name. Select a launch template. If by now you do not know how to create a launch template, I'll put a link on how to create a launch template at the top of my screen. Select Launch Template. Click Next. Select your VPC. Select availability zones. I'll select the public 1 and public 2. Click next. But if you have a load balancer, then you can attach to an existing load balancer. Or if you want to create a load balancer, you can attach to a new load balancer that you just created. So I'll select no load balancer for now. Click next. Let's keep our desired capacity at 1, our minimum capacity at 1, and let's say our maximum capacity will be 2. So what we are saying here is the amount of EC2 instances you want to be running at every time, at all times, should be 1. And then the minimum capacity of EC2 instances that you want to run at all times should also be 1. And then when there is a need for scaling up, your maximum number of EC2 instances you want to be provisioned should be 2. So it's not going to exceed 2. That's all. So if I make this 5, then it's going to be a maximum of 5 EC2 instances. Select your tracking policy, and we'll just leave it at default. So what it means that we are tracking for CPU utilization. So at 50% of our CPU utilization, it's going to flag off the ASG, our auto-scaling group, to create more instances. As long as the CPU is not utilized up to 50%, it's not going to scale any new instances. But if your EC2 instance crosses the 50% threshold, the auto-scaling group is going to come into action and create more instances to bring your target value down. Click next. Click next. Let's add a tag. Let's give it name. And then let's give it my ASG. Let's click next. And then we go through all the information that we have imputed and cross-check if everything is okay. And then we click create auto-scaling group. Here in the status, you see it's updating capacity. What that means is that it's creating the desired number of EC2 instances that we specified. So let's head back to our instance section. Click instances. Let's refresh the page. And there you go. That's our tag name, my ASG. And here it has provisioned an instance. So this is how to create an auto-scaling group. If you like this video and if you think you've learned something from this video, it will be a nice idea if you subscribe to my channel and put a comment below on the video you want me to create next. Let me hear your thoughts, and I'll see you next time. Goodbye. Hello and welcome back to my channel. Today I'm going to take you through how to create an EC2 Instance Connect endpoint service. Before now, we've been using Bastion host to connect securely to our EC2 instance in our private subnet. But today I'm going to show you how to use EC2 Instance Connect to do the same thing, gain access to your application in your private subnet, and while maintaining high availability and security. So if you look at the AWS documentation here is the schematic, and that's from the internet, using the EC2 Instance Connect endpoint service to gain access to our VPC via the EC2 instance connect endpoint, which means we're going to create an EC2 instance connect endpoint. And if you look at the schematic here, it's in the private subnet. So I want us to go ahead. We'll start from scratch. We're going to set up our VPC, create subnets. We're going to create route tables. We are going to create our internet gateway. We're going to create security groups. We're going to create the endpoint itself. We're going to go to IAM to create our permissions. We are going to also go back to EC2 dashboard to create our instance and then demonstrate this technology. So if we come to the documentation here, you will see how it works. First, you create an instance connect endpoint in a subnet in your VPC. Then, when you want to connect to an instance, you specify the ID of the instance connecting via CLI right in your local machine. We're going to look at how to do that. And you can optionally provide EC2 instance connect endpoint. The endpoint acts as a private tunnel to the instance. So this is what we're going to do. We're going to look at this schematic, we're going to build it, and then we're going to connect via this service, and we're going to also use our CLI in our terminal in our local computer. I'll put this documentation, everything about the documentation, at the description below. So let's go. We'll select our VPC. This tag here is for your name. Give it a name. Choose a CIDR number. Leave our tenancy default. Our name and tag. Let's correct the name. Our tag is good, so we hit create VPC. And there our VPC is created. Let's look for it, connect VPC. So we have our CIDR block. The next thing we do is go to our internet gateway and select create internet gateway, give it a name. Click create internet gateway. Select our internet gateway, come to actions, click attach to VPC, select our VPC, that's it there, click it, click attach to internet gateway. So we have successfully attached our VPC to our internet gateway. Now when you create a new VPC, it automatically creates a route table for you. So we're going to go through the route table. Let's get VPC, that's the ID. So this is it. Anytime you create a VPC, you will get a free route table, a default route table. It's called the main route table. So that's it. That's for this VPC. So we're going to select. Let's rename it as our public route table. We're going to create another route table. Hit create route table. Give it a name. Select a VPC, choose our VPC, click create route table. So we have our public route table as well as our private route table. So we're going to go ahead to create subnets. Select subnet, come to create subnet, select our VPC, go down to your VPC, and we're going to create one public subnet and one private subnet. I'll give it a name. Availability zone, let's choose US East 1A, give it a CID error number, click add new subnet, give it a name, choose availability zone, US East 1B, give it our CID error number, click create subnet. So we have 2 of our subnets created. Let's go to our route table and make all the associations. Let's start with our public subnet. So select public subnet, click routes, click edit routes, click add routes, select outbound internet, select our internet gateway as our target, and click save. Let's come to our subnet associations for public subnet, click edit subnet, select the public subnet, save it. We are done here. So what we've done is we've added our internet gateway as a route to send traffic outside the VPC. And when traffic comes into our VPC, it should also come through the internet gateway. We also associated our subnet with our public route table. So this subnet becomes a public subnet because we have an internet gateway attached to this route table. So we'll go back to our route table and do the same for our private subnet. This is our private. Select under routes, because we're going to use EC2 Instance Connect, we won't need to put any NAT gateways or any other thing. We're going to leave it blank. We'll come to our subnet associations, select, edit subnet associations, pick our connect private subnet, save associations. Good. We're done with that. The next thing we'll do is scroll down to security groups, select security group. Now let's go to the documentation to see how we can create security groups. So now if you look down here, you will see security groups for EC2 Instance Connect Endpoint. So here you'll see that you have 2 security groups to create. One is EC2 Instance Connect Endpoint Security Group, and the other one is Instance Security Group Rule. So what this means is that for our endpoint in our VPC, right, we have an endpoint that we will create. We need a security group for this endpoint. And then in our EC2 console, when we create our instance, we need another security group for the instance. So that's what you see here, these 2. So when you create this endpoint, you must have a security group for this endpoint, and you also have a security group for your instance. So 2 security groups are involved. So now in your security group for your instance must have your endpoint as its source. So in the inbound rules of your security group for your instance, you will select the source as your endpoint security group. So let's create our security group. The first security group we're going to create is our EC2 Instance Connect Endpoint Security Group. I'll pick the name from the documentation. I'll give it a description. I'll copy that, come back, paste, select my VPC, select SSH, then select my VPC CIDR block. So I'm going to type that. That's all we need to do here. So in our outbound rule, we select our destination as the VPC CIDR. Hit save. So we're done with that. The next, we'll click create security group. This time we're going to be creating for the instance. So we'll select our description. I'll give it a name. Select my VPC. Now I'm going to be using an inbound rule here. Add rule. I'll go to SSH, and in my custom rule I'm going to specify the source as the EC2 instance connect security group that I created as our inbound source. Create security group. So we have two security groups that we just created. So here we have the EC2 instance security group and the EC2 instance connect endpoint security group. I'll change their names. Great. Let's go to our documentation. So we are going to create two permissions to enable us use our EC2 instance connect endpoint. The first one is we're going to grant an IAM permission to use EC2 instance connect endpoint. What does this permission do? It allows users to create, describe, and delete EC2 instance connect endpoints. So that's what that permission does. So we are going to create it. This is an example of it. We're going to copy it and make note of this in red. We're going to customize it to our own details. So go to IAM, under policies, create policy, select JSON, delete what's here, paste what you copied, and then the region, we change it to our region. I'm using East, US East 1. And my account ID, come to the top right of your screen, copy your account ID and paste. That's all you need to do here. You save, you give it a name, and you close. I already created this policy, and that's it here. The next will be to allow users to use EC2 instance connect endpoint to connect to instances. So this gives us the ability for a user to be able to use an EC2 instance connect endpoint to connect to an EC2 instance. It sounds confusing, but that's what it is. So here we are going to copy this also and create a policy. Create a policy on IAM. Come to JSON, select it, delete what you have here, and paste. And we're going to remove the conditions. So if you click this condition, you will see the close curly braces here. So everything in between these two curly braces, we want to take them out. So we'll take all of that out. come back and dress it up well. And then the next thing we need to do is to change our region to our current region. I use US East 1. Our account ID. You come here to your account ID. You copy your account ID. Paste. And we don't want to specify a particular instance connect endpoint. We want this policy to work with any endpoint we create. So we're going to take these endpoint details out and put a wildcard. That's all we need to do here, and we give it a name and save. I already created this also, so I'm just showing you how to do it. So once we're done with those two, these are the two policies. We'll come to our VPC, and then we go to endpoints, and we create endpoint. We give it a name. Here under service category, we want this endpoint to be used by EC2 instance connect endpoint. If you remember our diagram, you see this service, we want this endpoint to be used by this service. That's what we're specifying here. So this endpoint, we want it to be used by this service. So we select that. We select our VPC. Scroll down, we select our security group, EC2 instance connect endpoint security group we created. We select our subnet. Let's put it in a private subnet. And we are good to go. So we create endpoint. This takes about 10 minutes for it to be fully active. So while that is going on, we're going to go to our EC2 and launch an instance in a private subnet of our VPC. So let's go to our EC2. Let's give it a name. We'll take Amazon Linux. I'll take Amazon Linux 2, still free tier eligible. I'm going to select my key pair, click edit, network settings, pick my VPC, so I'll refresh. Select my subnet, refresh, put it in my private subnet, select my existing security group, refresh. Now I'm going to put my EC2 instance security group, select that, and let's launch. It's running, so let's select this and hit connect. Select EC2 instance connect. Select your private connecting with using EC2 instance connect endpoint. And we wait. When our endpoint is active, we can find it here. But right now, it's still creating. Still pending. Let's refresh. It's still pending. So effectively what we've done is we are currently creating the endpoint. We created our VPC. We created our subnets. We launched our instance. We were able to get our route table route traffic to where we wanted. We were able to also associate our subnets with our route tables. We also went to IAM to create our permissions, one for EC2 instance connect endpoint and the other for the user, right, the our account user to be able to use EC2 instance connect endpoint. And we're waiting for our EC2 instance connect endpoint to be created. Okay, so our EC2 instance connect endpoint is available. So let's head back to our EC2 console and select our instance, click connect, select EC2 instance connect, select connect using EC2 instance connect endpoint, scroll down, select our instance connect endpoint. That's it there. There you go. And let's hit connect. And there you go. So we have effectively connected into our EC2 instance. That's the private IP address. We'll come to our instance, scroll up, go back, select the same private IP address. So the second way I'm going to show you how to connect to your instance using EC2 Instance Connect is via the instance ID. And we're going to establish connection with our local terminal in our local machine. So I'll go straight to show you how to do that. By the way, if by now you've been learning a lot of stuff, I think it's a good idea to subscribe, hit the like button, put a comment below to let me know what video you want me to create next. It helps me a lot. So let's go to the AWS documentation. So it says, and I'll put this document in the description below. If you scroll down, to connect to an instance using the instance ID, this is all you need. But before you do this, you must make sure you have installed AWS CLI in your local machine and you've configured your AWS CLI. I'll do a video on that. I use a Mac OS, so for you to install AWS CLI, the link I'll also put in the description below. This is all you need to do, these two commands. So you pick this first, that's the one you have on top, and then you pick the next one, which you have at the bottom. And then you check with which AWS and AWS version. So I'm going to go ahead to use this to confirm that I already have AWS CLI installed in my local machine. Right, that's it. So I have AWS CLI installed in my local computer. Let's connect to our instance with our instance ID. Come to the documentation and then we copy this, copy, we'll paste, we'll give a space, and then we'll come to our EC2 console and select the instance, copy the instance ID. Hit enter. Yes. Right, we are in. So we are able to SSH into the instance in our local computer, also using the instance ID. I hope you like this video. Put a comment below. Let me know what videos you want me to create next. I'll see you next time. Bye. Hello and welcome back to my channel. Today
Let's discuss the framework for a three-tier architecture. And here you see, as you can see, I have a three-tier architecture design. This is for beginners. And if you look at this architecture, we have a VPC, we have availability zones, 2 availability zones, we have 2 public subnets, there's the other one, we have 4 private subnets, 1, 2, 3, and 4. And we have 3 tiers in this architecture. So you have tier 1, which has 2 public subnets, tier 2, which has 2 private subnets, and tier 3, which has 2 private subnets. So basically, what a 3-tier architecture is a well-structured and commonly used architectural approach for building and deploying web applications. That's what it is. It separates the applications into 3 distinct layers, or you can call them tiers. Each of them has specific functions and responsibilities. So these layers, what they do is they work together to provide scalability, maintainability, and flexibility to your application. See, so the 3 tiers, basically they consist of your presentation tier, and that's your interface or your client tier, which is the topmost layer that interacts directly with the users or your clients. Things like your web browsers, your mobile apps, your desktop applications, these are all resources within the presentation tier. So basically that's what the presentation tier is. So if you have an app in your phone, that is part of your presentation tier. The application tier is the next level, right? And it is known as the logic tier or the middle tier. So what the app tier does is requests that come from the presentation tier are processed in the app tier, so it performs computations, and then it interacts with the data tier where you have the database. So the last of the tiers is the data tier or the storage tier or the back-end tier. It is responsible for storing. You can retrieve data from there. You can manage data required by the application. One thing you need to know is that all 3 tiers can be horizontally scaled depending on what your requirements are. So without any further delays, let's go straight to building a 3-tier architecture. The first thing, as usual, we're going to do, and you can do this with Terraform. Maybe one of these days I'll build a 3-tier architecture using Terraform. But I like to do this manually because it shows you, if you can do it manually, then it's easy for you to do it with an infrastructure as code application. So I create my VPC. I give it a name. I give it a CIDR block. And I leave my tag, and that should be good. Next thing, I'll go to my internet gateway, click create internet gateway, give it a name. We have our tag there, create internet gateway. The next thing I need to do is to come to my subnets, click create subnet, select your VPC. From our schematic, what we're going to do here is we're going to have 2 public subnets and 4 private subnets. We're going to have 2 route tables, route table for the public subnets and a route table for the private subnets. This is the first subnet, I'm going to give it a name. I'll copy that because I'll use it later. Let me put this in my availability zone A. I'm using US East 1 region. I'll give it a CIDR block. I'll add a new subnet down here, click it, scroll down, give it a name. I'll give it public subnet 2.
put this in US East 1B for high availability. Give it a side block number. Click add new subnet, scroll down, give it a name. Let's put it in US East 1A. Take our cider block. Come down here, click add new subnet, scroll down, give it a name. What I will do is I'll change the names when I'm done. I'll assign my cider block. So I'll just change the name to follow my tiers so that it's easy to locate which subnet is in which tier. So we have two web tiers, which are public subnets. We have two app tiers, which are private subnets. And then we're going to have click add new subnet. We're going to have the last set, which is the data tier. Select our availability zone. I take US East 1A. I'll give my cider block, and we'll take our last of the tiers of the subnets. Okay, I'll choose my availability zone B. Okay, so I'm going to do some cleanup on the names. Make sure everything is okay. I'm building according to the architectural diagram. We have everything in place. Click create your subnet. Once it is done, we're going to do some routing. They are all done, so we're going to do some routing. One thing you will note about VPC is that whenever you create your VPC, you have two resources that are created automatically with your VPC. One is a security group and the other is a route table. Under our route tables, we look at our VPC. This is our VPC. So this is the one that is created by default with our VPC. We'll give it a name. What we will do, we'll go back to our internet gateway. We select our internet gateway. We come to actions attached to VPC. Select our VPC. That's our VPC. We attach our internet gateway. So when we go back to our route table, we select our route table. We come down to routes and we click edit routes. We will be able to add a route whose destination is outside our VPC, and we select that any traffic going outside our VPC should target the internet gateway. Select that. Yeah, we have our internet gateway here. We're going to now associate our subnets with our public route table. So under subnet associations, we'll come down to edit subnet association. And then we pick our public subnets. We have two public subnets. So when we come here, we see that we have public subnet 1 and public subnet 2. And this is going to be in our web tier level. So we're picking those two subnets. We associate them. We hit save. Come back to our route table. Click create route table because we need a second route table, a private route table. Select a VPC, click create, and now let's associate our private subnets with this route table. So we click all the private subnets, So we have done the routing and the associations with our route tables. Now we will come to our NAT gateway. We are going to create it. We are going to route our gateway to our private subnets. So under route NAT gateway, click create NAT gateway. Come here, give it a name. Select a subnet. Before we do that, let's come to our architecture. You see that our NAT gateway is in our public subnet. So we will put our NAT gateway in our public subnet. I'll choose public subnet 1 like you have here. The connectivity type is we want it to be public to have access to our internet gateway. So we allocate an elastic IP. If you have one, then you just select it. But if you don't have, come here, click allocate elastic IP. That creates an elastic IP automatically and associates it with your NAT gateway. We are done here. Click. Now you see I have my tags. If you notice, you will see that I've always been adding tags. Don't create infrastructure without tags, because under identity access management, you can secure your infrastructure just by the use of tags. So it's important that you always tag your resources when you create them. If you think by now you're learning something and you're gaining value, do well. Can you just subscribe and hit the like button, put a comment below? It helps me a lot. So from here, we come back to our routes, and then we associate the NAT gateway with our private route table. Remember, it was created in our public subnet, but we are going to associate it with our private route table. So we look for our private route table here, and then we come to routes, and then we edit route, add route. Any traffic going outside our VPC from the private subnet, from our private subnets, targets the NAT gateway. And that's our NAT gateway there. Click save. Our routing is done. We are going to now move on to the next stage of creating security groups. We are going to do a concept that I call daisy chaining of security groups. So how that works is that when traffic comes from the internet gateway, from this architecture, you see that it hits an external load balancer that will distribute the traffic to the instances within this target group that we are going to create. So we are going to create a security group for the elastic load balancer. We are going to create a security group for the instances that will be in this target group. We are going to daisy chain this elastic load balancer security group to the security group of the instances in the target group. We are going to daisy chain the security group in the instances of the target group to the internal load balancer, elastic load balancer in the app tier. We are going to also daisy chain the security group from the internal load balancer of the app tier to the instances in the target group of the app tier, so on and so forth. Same thing with this. We are going to daisy chain it with the security group of the data layer. So that way, traffic only comes from one source. We don't expose many sources. So that's what we're going to do next. So we have so far created the VPC, internet gateway, public route table, private route table. Availability zones have been declared, subnets have been created, and associations and routing have been completed. NAT gateway has been created in the public subnet, and it's been associated with the private route table, right? So we are done here. Let's go and create our security group. So under security groups, now if you go look for the the VPC ID of this the security groups, you'll discover that there is one that is standing alone here. So let's look at this VPC. It ends in 0cc. Go back to our VPC and look for our new VPC we created. You see it ends in 0cc. So that's the default security group. We're going to select, let's name it as the first security group, which will be the external load balancer. So what we're going to do is to set our inbound rules. Simple. Inbound rules, it means how will traffic get into your load balancer and where is that traffic coming from. So we're going to say all traffic comes from anywhere on the internet. This is all we need to do here, just to ensure that the load balancer receives traffic from the internet. The next thing we're going to do is to change the type of protocol. We're going to use HTTP. So we are saying here that as long as people from the internet come via HTTP on port 80, they will be allowed to access the internet load balancer. They will be able to hit the internet load balancer. Now, I don't have a security certificate for my application, but the way it usually would go is that we will take HTTPS. In a real life environment, you will use HTTPS port 443. In that situation, you will need to provide your certificate, right, when you create your load balancer and all. So, but we don't have that. This is how it should be in real life. But I'm going to use port 80 because I don't have a certificate. So that's all you need to do here. We click save. We go back, create security group. This time we're going to create the security group for the instances in the web tier. So we'll now say that's it. We're allowing traffic only from the security group of the external load balancer. Select our VPC, add our inbound rule. In our inbound rule, we are going to go to the same HTTP. Here, we're going to search for the external load balancer security group, and this is it. So we'll select that. So this will be the source, the only source from which this security group will allow traffic. We'll add another rule, and this will be an SSH rule so that we can access our servers if there are issues. And this, I'll leave it open. Scroll down, add a tag, come back to our security groups, click create security group. We are going to now create for the internal load balancer of our app tier. We're going to choose our VPC, add our inbound rule. Here we're going to select HTTP, and then we're going to look for our web tier security group. That's all we're going to do here. Add a tag of name. We're going to now create the security group for the application tier. Now let's select our VPC and come to inbound rules. We're going to select HTTP and we're going to select the internal load balancer of the app, the security group of the internal load balancer, and then this is a security group for the app tier instances. So we also want to SSH into them if we have any issues. So we'll create another rule and select SSH, and we'll also leave it open for now. That's all we need to do here. We'll give our tag. So we have 4 security groups. We have the elastic load balancer, we have the web tier, we have the internal load balancer, we have the app tier, and now the data tier is what is next. So let's click create security group. Here for databases, if you look at our architecture, we are using MySQL, which runs on port 3306. So we'll look for the protocol, MySQL, Aurora, and that's what we need to do there. And then we come to our source and select our app tier security group. That's all we need here. We'll create a tag. So we are done with creating our security groups. They are all created. If I filter for tier, we have our load balancer, the elastic, and application load balancer. We have, so traffic leaves this and comes to this web tier. It leaves the web tier and goes to the internal load balancer of the app tier. It leaves there and goes to the app tier. It leaves the app tier and goes to the data tier. That's the way we set it up. So having done all these, we need to now go to our EC2 and create our launch template. Because if you look at our architecture, you will see that we have an auto-scaling group that is launching instances automatically for us. This helps in high scalability. We're using 2 availability zones for high availability. This gives us the advantage of high scalability. And then our target group is going to span across both availability zones and both subnets in both the web tier and the app tier. So now to launch a template, we click launch template here. There are going to be 2 launch templates, one for the web tier and one for the app tier. So we'll start with the web tier. We'll give a description. We'll select this because we need to use it for auto scale. We'll give a tag to the template. Okay, so we are not picking from any source, so we'll leave that blank. For our AMI, we come to quick start. Let's pick our Amazon Linux. I'll use Amazon Linux 2. The instance type, I'll leave it as T2 micro. Then our key pair, I'll select my key pair. In my network settings, I'm going to leave out the subnets. I want the auto-scaling group to determine which subnet the instances will be launched. I don't want to lock down the instance to a subnet. Let the auto-scaling group do its work. So I'm going to leave that empty. Then I'm going to select an existing security group. This security group is going to be the web security group, the security group for the instances that will be launched in the web tier. So we already have that, so we look for it. And then volume, 8 gig is okay for this lab. So we'll come to our advanced. This is an Amazon Linux instance. So I'll say sudo yum update. So when the instance is launched, it's going to carry out all these commands to update the package manager, to install HTTPD Apache, to enable it, to start it, and then we are going to copy this code into this file so we can view it in our web page as a web page. So let's create our launch template. This time we're going to create for our app tier launch template. This template actually will contain the logic application, which you will not see, but I just want to put something inside so for us to be able to prove that we can gain access to the app tier. Let me use Ubuntu for this. My instance type will be T2 micro. Select my key pair. I will not select a subnet. I'll let the autoscaling group do that. I will select my existing security group we created, which was the app tier security group. That's it here. And I'll scroll to my volumes and make sure I have volume. Okay, this is enough. And I'll come to my advanced details, and I'll also put just a small code. This is Ubuntu, so we will say so let me add sudo. I think I'm missing sudo, and create launch template. We'll come back to our launch template. Let's edit our web tier to include the details in our data, advanced details. I want to include sudo there. So let's modify launch template. Let's select that. I'll just scroll down. Everything remains the same. I just want to add sudo here. I don't want anything to fail. Create launch template. Everything remains the same, but I'm going to use version 2. So in the web tier, I have 2 versions. I'm going to use version 2. So if I come to my advanced details, I have the sudo there. Right, so we are done with the launch template. Let's go now to create our target groups. Hit create target group. We are going to be targeting instances, so we'll use that. And we'll give our target group a name. We'll leave our protocol and ports the same. We'll select our VPC. We'll leave these ones pretty much the same. We'll give it a name, tag. We'll click next. We've not created our auto-scaling groups, so there will be no instances to register to our targets. So we will create our target group. Create another target group for the app tier. We're also targeting instances. Select our VPC, give it a tag, save. No instances to register yet. We click create target group. Let's create our load balancer. Create load balancer. Here we have 2 load balancers, one external and one internal. They are both application load balancers, so we are going to start with the web load balancer, which will feed the web tier. Application load balancer. It will be internet facing, so you keep it at that. We'll select our VPC and we'll allow it send traffic to both availability zones that we defined when creating our network infrastructure. Here, this external load balancer, let's look at it, is sending traffic to public subnet 1 and public subnet 2. So we are going to select these two subnets. Check for our public subnet. That's public subnet 1, which is a web tier subnet. Public subnet 2, which is a web tier subnet. Our security groups, deselect that. We created security groups for our external load balancer. You remember? It's actually the default security group. That was the first one we used. So we're going to select that. We're going to register our target group. We created a web tier target group for the load balancer to send traffic to, and we're going to leave everything here pretty much the same. Create load balancer. While it's creating, we'll go ahead and create the app tier load balancer. We'll do exactly the same thing. Here, we're going to make it internal facing. So this load balancer doesn't have direct access to the internet. That's what we're saying. It's going to be feeding the app tier. We're going to select our VPC. And then we'll also select our availability zones. Now for the app tier, which is this, we have two subnets, private subnet 1 and private subnet 2. We're going to add those to this app tier, this load balancer. So not the data tier, the app tier private 1 and the app tier private 2, correct. Security groups, we created one for the app tier load balancer, the internal load balancer, so that's it here. We'll select that. Target group we already created for the app tier, select it. And we click create load balancer. Did I give a tag? Looks like I forgot to give a tag. So they are provisioning. We'll go ahead while it's being provisioned to create our auto scaling group. Guys, this is our final stage. If you've learned a lot so far, if you think you have been providing value to you, kindly subscribe, kindly share. If you're not going to subscribe, share. If you're not going to share, comment. If you're not going to comment, like. If you're not going to like, then click the bell button. Right? So here I'm going to give our auto scaling group a name, the web tier auto scaling group. The launch template we're going to be using is going to be the web tier launch template. Remember, we created launch template for that, and we modified it. So we're going to use the version 2 that we actually modified. So we're going to use that. Let's create next. Select your availability zones and subnets. Here, this auto scaling group is for the web tier. Right? So we are going to be dealing with public subnet 1 and public subnet 2. We're also going to be dealing with availability zone 1 and availability zone 2. So those are the areas we're going to focus on. So let's look for our public subnet 1 web tier. Let's look for our public subnet 2 web tier. And let's click next. We have a load balancer, right? So we click attach existing load balancer, and here we'll click our load balancer, which is a web tier load balancer. We'll pretty much leave everything the same. We'll select that, it's recommended. We're not going to, this is just a framework, like we're setting up a framework that we can build upon and develop further. So we leave this and we click next. Here, this is the area that helps us set the desired number of EC2 instances, the minimum number and the maximum number. So let's say the maximum number is 3. So let's go ahead and establish our target tracking policy, and that's it. So let's click next. This is for setting up SNS topic and email notifications. We'll skip that. Click next. We'll add a tag. Next. And we review what we've done so far. Make sure everything is all the way the architecture is designed to be. Click Create Auto Scaling Group. We'll go ahead and do the same for our app tier. Click our launch template for app tier. Click next. Select our VPC. Select our subnets and availability zones. The same thing we did for the web tier we're going to do here. We're going to look for the app tier private 1, app tier private 2. Click next. Okay, so we're here. We select our load balancer we created for the app tier. That's it here. We select that. We scroll down. We turn on Elastic Load Balancer health checks. So this makes the load balancer go every period to check the instances to see if they respond. If they don't respond after a grace period, then it flags them as unhealthy and it stops sending traffic to those instances. Click next. We'll leave this the same. We'll come here and turn the maximum capacity to 3. And then we enable target tracking scaling policy. So let us click next, next, add a tag, and click next. So this is all the summary of what we've been developing, and then we click Create Auto Scaling Group. So by now the web tier auto scaling group should already have instances running. If you come to the web tier, you will see we have 2 instances running. One is the desired capacity is 1, the minimum capacity is 1. So it looks like it is flagged 1 as unhealthy. But we'll go and check something. Let's go to our target group and see our web tier target group. We see that it's flagging 1 unhealthy. That's why it's creating a second one. When it shows draining, it means it's deleting the one that is flagged unhealthy. So we are going to go up. You see, once you create your auto scaling group, your target group will automatically register those instances that are created. If we come to our instances, you will see that you have instances that are already running, and they will bear the name of our auto scaling group. So you see we have 2 for the web and 1 for the app. This is initializing, which means once it's done and it passes the health check, the first one that is already running will be terminated. So we can do a check right now. So let me see this. Both are running. So I'll terminate. Let's just terminate the instances to see what will happen. We'll just wait. We will see a new instance from the web tier spin up. Wow, that's it there. There's a new instance spinning up. I want us to go into this instance once it starts running, and also SSH from here to access the web tier, the app tier. But before that will happen, once the instance starts running, I want to access it on the web, right? So for you to access that instance on the web, because we have a load balancer in front of it, which is this, I will use the DNS record of this load balancer to access the instances inside this target group. So let's go ahead and do that. Come to your load balancer, select your web tier load balancer, scroll down, copy the DNS name, let's paste that. Yes, so what we effectively have done is we've been able to gain access to the web tier, right? This is what the clients will see. This is what you see on your phones when you check on your apps. This is the interface that you get to see. So you actually hitting on the load balancer and not the instance and not your application directly. So the load balancer, the traffic is going from the load balancer through the security group of the load balancer to the security group of the web instance and allowing that to get to the web instance. So that's why we're viewing this. So this is good, right? So what we can do here, we cannot do the same with the app tier because the app tier is not internet facing, right? It's internal, it's not internet facing. So you can't check it online. So I will go back to my instance and SSH into my SSH into my web tier instance. From there, I will gain access to my app tier. Let's check if we have our code in place in our app tier. So we click web tier, connect. Under our SSH client, we select our commands. We'll come down here to our terminal. I paste my command. Yes. Great. We are in our web tier web tier server. So what we'll do is let's check what we just saw on the web if it's actually here. So all I'll do is to cat my var and HTML, an index.html file, yes, this is the web tier. That's exactly what we saw here, right? That's what is inside our web tier application, our web tier server. So the next thing we will do is for us to be able to SSH into our application tier to carry out some tooling jobs and maintenance jobs. You can't SSH directly unless you have a key pair, right? So we already have a key pair. So what I will do is go to my .ssh file folder. If I ls, I have my public key in my authorized keys, but I don't have my private key pair. So I'm going to vi my private key pair. I'm going to bring it here into my server. I'll create another tab, clear the screen, and I'll use secure copy. I'll specify my key pair and I'll specify the file I want to copy. And I'll specify the instance I want to send the file to. So we're going to get the public IP of the instance. It's creating more because it's trying to, you see, this is a back and forth thing. You have to set your permission, your checks and health checks. You have to set all that very well to make sure that it registers only one instance on your timeline. So this is my public IP. and then I'm going to specify where I want to put the file. Okay, so I've securely copied it to my server. So I'll close this, come back to my server, CD to my home. When you ls, that's my key pair there. So I'm going to move my key pair to my SSH folder. Okay, so if you CD to our SSH folder and we ls, I have my key pair there, and next I'll give permissions. Great. So with this, I can now SSH to my app tier instance. So SSH-I my key pair, private key pair. This is Ubuntu now. Remember, we used Ubuntu. And then I'm going to get my private IP address from my Ubuntu. So we are in our Ubuntu. See that? So let's verify if our code is also in our Ubuntu. In Ubuntu, what we said was, let's come back to our launch template. In our app tier launch template, we chose Ubuntu as our server, and if you scroll down to our advanced details, we gave a command there. We said this is the app tier. So let's check if that's also in here. So we're going to cat var this is the app tier. So we've effectively set up our app tier, which is a logic tier where all the computations happen, and this app tier has direct access to our database to pull data from the database. So I log out. So I don't want to make this video too long, but if you like what you've seen so far, I'll stop the video here. What we've been able to do here is we've been able to set up a 3-tier architecture. We created a public app web tier. We also created an app tier. The data tier, what we're supposed to do there is, let me come here, is to come to our RDS and create a database. So I'm going to do this in the part 2 of this video. I don't want the video to be too long. I'll see you guys next time, and take care. 2 hours aside the download. We're going to be installing Ubuntu 20.4 LTS in VirtualBox, long-term support. LTS, that's what it means. Go on Google and type Ubuntu. Make sure you're in Google where you have the Ubuntu website, and click on downloads. It opens up. Yeah, the desktop version is what we want. So we'll click on that, and then it takes us to where we have the ISO file, which is the actual software. Take a very good look at the system requirements. Make sure your computer exceeds or meets these requirements. we will not use a USB or a DVD. So don't worry about that. So let's click on that. Forget about signing up for anything. Just wait for it to download. So open up VirtualBox. Now in the new tab, yes, the new tab, click on that. Put your name or whatever name you want to put, and then look for the newly downloaded file. All this is sped up in this video, but because the file is about 6 gigabytes, so it will take a good while. This whole tutorial will take about an hour plus to install. Click on next. Here you have your username and password. Ensure you change the username from VBox user. If you want to keep it, you can keep it, right? And then put a new password. But remember these info because you'll need it to log in. Here we need your processor. You can make it 2-core and you leave your memory the same. Then your disk, leave it at the same. And this is a summary of everything. Click finish and wait for your Ubuntu operating system to begin the installation process. So this whole installation will take not less than an hour, but I'm just speeding everything up. So from here on, it's going to take a while to load, to download, install files, packages. You just have to be patient. Okay. You have to be patient here. Just ensure you have enough memory allocation and CPU core so that it won't fail. The installation will not fail. So it's good to leave your memory, the default memory allocated to you, but the CPU you can move it to 2-core or more depending on the spec of your processor. So Ubuntu is a Linux flavor. It's about the most widely used Linux flavor. You've got Red Hat, you've got all the other types. Okay, installation done. And the operating system is booting up. So you have to give it some time to boot up. Okay, we are done. You remember the username you entered at the beginning. Put your password. Ensure it's the correct password. And hit enter on your keyboard.
Are you overwhelmed with identity management in the context of omnipresent threats to your organization?
Hi, so no one knows what that means.
What's happening?
Just explain I walk to help secure digital identity. Keep it simple.
Like what?
Like when delivering a fresh uniform. Or viewing your results. Yeah, it's that. Or making Brad swoon at the high school reunion.
Oh, I love that color. Phew, that was a lot.
Oh, there's more. Like, lots more.
I have the craziest story time to tell you guys. I just got home. Lunatic. I don't know what to eat. Sauce on my food. From Bulldog. Bulldog. My goodness.
Oh my God! Look who I'm here with. I'm with all.
So these you just skip all these, next, skip, just click next, next, click that tab at the bottom and search for terminal, double click on terminal. So we are here on terminal, but if you look, it's so small. Don't upgrade, just cancel the upgrade. Go to view and click on scaled mode and switch. So now we have a bigger terminal view. Okay. Our package manager. If you have this error, I'll show you the first solution. There are two solutions. So the first one is to use this command. Enter your password, the one you use to log into this operating system, and then once you're done, you use this command that you're seeing there with your username that you specified at the beginning. Basically, this is it. You can now log out. And that's one way to do this. So the second solution is to go into the vsudo file, go to your root and type that command and scroll down to, I'll put a red rectangle to show you where you need to make changes. Yes, exactly there. Put your name, the name you used to log in, and then space, and every other thing you see on top, just type the same thing, and then you close this page. I'm going to put the command to close from this page. I'll send it to you so you will see. So these are the two solutions. We exit and then we come back to update our package manager, and you see it will run. Put your password and that's it. So a lot of these installation process was sped up. Just be ready to go through these. Just prepare at least 2 hours aside the download stage of the installation file. If there are any issues during your installation, don't forget to reach out to me in our Telegram group, and we'll sort it out. But talk loud, you need to learn this stuff. So the package manager is done. Thank you for getting this far. You'll do well as we proceed. Let me stretch the screen a little bit with the training. Goodbye, and see you in the next lab. Now this installation, we're going to be installing Visual Studio Code and VS Code for short. As usual, go to your Google and in the browser type Visual Studio Code, and then make sure you are in the actual website, and then click the download link. So it takes you to Visual Studio Code website. We are dealing with Windows, so click the blue rectangle Windows for Windows 10 and 11. And then we wait for it to download. Okay, so we use Visual Studio Code to, it's like an all-in-one application that helps you. It has terminals for you to be able to access your operating system. You can write code, you can write scripts, you can write technical documentation, right? It's called an IDE. IDE is called, it means Integrated Development Environment. We're going to look at, how to work with Visual Studio Code also. So you can, it's a multi-purpose application. Ensure that you follow the process. It may be a little different from in your computer, but by and large the options are still the same. And if you have any issues, let me know. Reach out to me in the Telegram group, and I'll take you through to solve the problem. I think we're about done with the download process. Okay, so we are done. The download is complete. Okay, so we double click on that, close the window, and then we agree to the terms and just click next, next, next. We select that option to leave it on our desktop. Next, install. So this is one of the easiest installation go through. I think so far the most difficult of them will be Ubuntu, and it's also the most lengthy of all. So we are good to go with Visual Studio Code, and let's click finish and it will launch. There you have it. This is the integrated development environment, the IDE, Visual Studio Code. So I hope you like this tutorial. I'll see you in the next lab. This lab, we're going to go on Google to learn how to install Git in our local computer, right? So that's what we want to do. So type Git in your Google browser and hit enter, and make sure you are with the one that has git-scm.com. Go to the downloads for Windows, or we are dealing with Windows installation here, and under there you will see the 32-bit under standalone installer. Don't use that one, use the 64-bit Git for Windows setup. Yes, that's the one, because most of your computers will be 64-bit. So we'll wait for it to download. We're going to be looking at Git in detail in one of the classes. We might take about 2 or 3 days to look at Git, but okay, so the download is done. I want us to basically get all these installations behind us. So we can now double click on Git and straightforward, just click next, next. You don't need to do much. Next, 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 next. Click next. Let's look at that. Yeah, we'll leave it. We'll use it for third party also. So we'll click next here. And yes, we'll leave it for OpenSSH. We will click next. We'll also click next. Most of these parameters, you just leave them as default and click next. 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 Same thing. Same thing, and we'll click finish, install. So Git installation is very simple and straightforward, but your Windows environment may be different from mine. I use a Windows 11, but by and large, the installation process is still the same. You're going to still encounter the same questions, parameters, and options. If you run into any issues, don't fail to drop a comment in the Telegram channel, and we will handle it. But I want us to all finish this stuff before we start the training so that everybody is is ahead of the installation process. So do well to follow up and ensure you complete every one of the installation that we're doing. All right, so we should be done with installation of Git. Okay, let's engage. Let's check launch Git bash and deselect the second one. Deselect this one. Yeah, click finish. So we have Git bash running in our system. It's just a terminal, right? So we can start checking files and whatnot. So thank you for watching. Okay, so this is how to install Git in the VirtualBox environment. You just use sudo apt install and then space git and -y, and that's all you just need to do. Enter your password and you log in, and then Git is installed. It's a pretty straightforward process. It doesn't last. This whole lab for Git will take shouldn't take more than 5 minutes and you are done. After this, we are going to confirm that Git has been installed. Okay, so let's confirm that Git has been installed. So I'll just let you know, test. To confirm Git installation. Right, that's all I want to do here. So what we'll do is to type Git in space no Git space -- version. All right, that's it there. Git version 2.25.1. So here you go. Git has been successfully installed. Thank you very much for joining this lab. Okay, so I'll type it. Thank you for watching. I'll see you in the next lab. This will be an installation of Mobac stem. If you want to use another sort of an IDE, but it's not really an IDE, right? Go on Google, type Mobac stem in your browser, and let's download it. It's also a very good terminal for Windows users. So you click on Mobac stem and show you are in the right link, using the right link. And then let's take the home edition, the free one. Click on download. And let's use the previous stable edition. That's the portable version 24. Let's click on that and wait for it to download. So Mobac stem is like the new way, the new application server, but Movaxtem makes it easier for that to happen. So we're going to look at each and every one of these applications we're installing to ensure you understand why we are installing them, and what use they are for. The download is completed. We can close that terminal. We'll go straight to where we've downloaded it. Double click to get the file out. Right, the Movaxtem file we can now extract. When you double click, it will show you the option to extract. So click on extract.